So today we're going to do derivatives. So what's a derivative? First, let's draw a graph because this has something to do with graphs. So this is the y-axis, this is the x-axis, and let me make that arrow look nicer. So that's the x-axis, and then let's say we draw like a random curve. Okay, we can just draw like this curve right here. Or I guess we can make it a bit better. Okay, like that. So basically we all know what a slope is, right? Or we should know what a slope is. So S-L-O-P-E, slope. The slope of a graph. So the slope of a line graph. The slope of a line. We can find that using m. So if m is the slope, then the slope of a line graph is y2 minus y1 over x2 minus x1. So basically, if I drew a line like, so what this means is if I took 2 points on this graph and, for example, these 2 points, and then I drew a line between these 2 points, so if I connected these 2 points together, and I have a straight line right here, because 2 points define a straight line, right? What's the slope of this line? Well, I could use the equation of this graph to figure out the y coordinates and x coordinates of these 2 points. So if this is x2 and this is y2 and this is x1 and this is y1, then the slope of this blue line right here would be y2 minus y1 over x2 minus x1. So that's like the basic idea of the slope of a line. Now a derivative is basically, the slope of a point. The slope of a point, and not just how do you find the slope of this random point, right? Not just a point. The slope of a point on a curve. Or I guess you can also say on any graph. But we're going to use curves as an example right now. So how do we do that then? So what this means, what a derivative is a derivative is a value, and we can find the derivative of a point on a curve. For example, this red point on this curve over here, which is like a quadratic graph, by moving the black dot right here closer and closer to the red dot each time. So right now it's kind of far away from the red dot. Now we move it a bit closer and we can like draw a new blue line. This time this blue line will have a slightly different slope than the last blue line. We can move again this black dot more closer, and let me use green now. So now we have like a new line over here with another slope, and then if we move this black dot right here very close to the red point, then this would now be the green line. And as we move the black dot closer and closer to the red dot, eventually the distance between the black and red would be so small you can't like see it. Basically it would be like 0, like the black and red dot overlap, and like for example it's that close and you basically can't see much difference with the naked eye, right? The naked eye. So if it's like that close, they basically kind of overlap each other. So now if you draw this line in yellow, wait, how do you draw this? So like that, I guess. Now the slope of this yellow line, when the red and black dot overlap, would be the derivative of the red dot on this curve. So what this means is that if I redraw this curve over here, essentially what the derivative is the slope of the tangent line that is tangent to the curve at a specific point. For example, I want to find a derivative of this red point on this curve. All I have to do is find the slope of this yellow line, which is tangent to this entire curve, specifically on this point. Like, that's all I have to do. I have to find the slope of this yellow tangent line. Now, yes, that's all I have to do, but that's kind of actually a hard thing to do. Because, to be honest, we only know one point on this yellow line, which is this red point, and we can't really find the coordinates of all the other points on this yellow line. So what we can do is use the concept of limits to find the slope of this yellow line. The slope of this yellow line would be, so say we have a blue point, which we move closer and closer to the red point until they overlap each other, and you get the idea. Then let's say that this blue point and this red point have a vertical distance of y, or I guess okay. So we can say this blue point has coordinates of x2, y2, and this red point has coordinates of x1, y1. So we know that as y2 minus y1 gets smaller, or as x2 minus x1 gets smaller, so we know that the slope formula is y2 minus y1 over x2 minus x1, right? Now, as the blue point gets closer to the red point, y2 minus y1 and x2 minus x1 are going to get smaller. Now, what is y2? y2 is f of x2 minus x1. F of x2. And what's y1? y1 is f of x1. And then we have x2 minus x1. And we want to make sure that x2 minus x1 gets smaller and smaller. So we can use the limit thing. We have the limit as x2, the absolute value of x2 minus x1 approaches 0. So as the 2 points overlap, this, whatever this is over here, is going to be m, our slope of the yellow line, or the derivative. So in other words, you can write, so in other words, if I redraw the curve again, and I call this red point, I say this red point has coordinates of x and y, and this blue point has some other coordinates, and the difference in their x coordinates, is h, then I can rewrite this whole thing as m equals the limit as h approaches 0. So as the distance between the 2 points becomes smaller and smaller, f of x minus h, so the x coordinate minus that difference, minus that distance, minus f of x over h, or you can say over x minus h, which is this thing, minus x, which basically sums up to negative h. Or in other ways, you can write this as f of x plus h minus f of h over h. So both ways work. So this is the definition of a derivative, or the formal equation for derivative. In simple terms, it's just the slope of this yellow line over here, which is tangent to the graph on the red point. So after someone invented this derivative thing, which I forgot who invented it, they figured it would be nice if I knew for every single point on this specific curve, for every single point that I wanted that exists on this specific curve, I want the equation of the derivative. So how do we do that then? Well, all we have to do is, we just need the equation of this curve right here. Let's say that is y equals, or you can say f of x. So the equation of this graph is f of x equals x squared plus 5. Then if we plug this thing into the top of the definition, then we know that m is going to be the limit of 8 as h approaches 0, and the f of x plus h is just x plus h squared plus 5, while we subtract that from x squared plus 5 over h, which, so that equals the limit as h approaches 0 of, if we expand the top, we have x squared plus 2xh plus h squared plus 5 minus x squared minus 5 over h. And then the 5's cancel out, the x squares cancel out. So we're left with the limit of h as h approaches 0 of 2xh plus h squared over h, which now it's pretty obvious we can cancel the h's out because that's a common factor. So now we're left with one term, very simple, no fractions. So now we're left with 2x plus h. So now we simply have to plug in h equals 0 because we don't have to worry about the denominator becoming 0 because there's no denominator anymore. So when we plug in h equals 0, we know that this thing is just equal to 2x. So m equals 2x, meaning the derivative of this graph is 2x. Now, what does this mean? This means if I take any single point on this graph, for example, this random green point over here, and I want to find a slope, or I want to find a derivative of this green point on the graph, then so basically I want to find a slope of this yellow line. Then I can simply plug in m equals 2x. So I simply need to know the x coordinates of this point. Say the x coordinate is, the x coordinate is 7. So the y coordinate would be 49 plus 5, which is 54. So then this means that the slope of this yellow line here is basically x squared plus 5, or the slope of this yellow line is m equals 2x, which is 2 times 7, which is 14. So that is the derivative of this point on this graph. So now let's try another example. Let's say that f of x, wait, what's this? Okay, anyways. So let's say that, wait, this is a Spotify ad, oops. Okay, so let's say f of x is x minus 7 squared plus 2x minus 10. And we want a derivative of this equation. So we know that by definition m is the limit of, as h approaches 0, of f of x plus h minus f of x, and that's over h. So m is basically the limit as h approaches 0 of, so we can plug x plus h in. So we have x plus h minus 7 squared plus 2 times x plus h minus 10 minus x minus 7 squared plus 2x minus 10 over h. Now we evaluate that, which isn't that hard as it looks. So first we have x plus h minus 7 squared. So that's basically x plus h minus 7 times x plus h minus 7. So if we multiply everything out, we have x squared plus hx minus 7x plus, so we have plus 2hx, and then plus h squared minus 14x minus 14x plus 14.9 minus 14h, and yeah, that's about it, because we're supposed to have 6 terms. Wait, or are we supposed to have like 9? Wait, okay, this is kind of wrong. Okay, x squared, and then we have xh, and then negative 7x. We have hx, and then h squared, and then negative 7h, negative 7x, negative 7h. Yeah, that's right. And then we have plus 2x plus 2h minus 10. And then minus this stuff, which, yeah, it just gets more complicated. So minus x squared minus 14x plus 49 plus, or minus 2x plus 10. So we have the 2 x's cancel out, plus 10 minus 10 cancels out. This simplifies to, so this thing is basically minus x squared plus 14x minus 49. 49 and negative 49 cancel out. 14x and negative 14x cancel out. Negative x squared and x squared cancels out. So now and then we have all this like over h. So we continue to evaluate. We have 2hx plus h squared minus 14h plus 2h. Anything else? Nope. All canceled out over h. So now we can factor h out and cancel it out because we have a denominator. So that's just 2x plus h minus 14 plus 2, which this thing is like minus 12. So now we can plug h equals 0 in because we don't have to worry about denominators being zeros anymore. So now we have 2x plus 0 minus 12, which basically simplifies to 2x minus 12, which that is our derivative. So now if I want to find like the derivative of any point on this graph over here, say we have x equals like 6. If x equals 6, then m would be 2 times 6 minus 12, which is 12 minus 12, which is 0. So that's all for today. Next lesson, we're going to learn the power rule, which makes finding derivatives a lot easier.